Kia ora, Year 12 and Year 11. This is an ancient scholarship calculus question from before I was born. It's a very short implicit differentiation question. So it's got the product rule in it and implicit. If you're watching this in this year's A-level class, you should find this reasonably slow. I'm going to try and make sure that you've understood how to link up the product rule and implicit. If you're watching from last year's A-level class, you're probably going to find it way too slow, because by the end of the year, you guys got really, really good at implicit differentiation. And if you're watching and you're from level 3, you haven't done this yet, so don't stress out, you'll do it soon. So we're given an equation, and it's got y is equal to x times e to the y. And we have to show that this is true. So why do I think of implicit differentiation? Well, it's because here I've got stuff with x and y combined on that side. So there are other ways we can do this that are a bit easier. One idea that we'll get to later on is we could take logs of both sides, right? So we could go ln of y is equal to ln of x plus ln of e to the y. So actually I'm going to pursue this because this is quite nice. So we get ln of y is equal to ln of x plus y ln of e, and y is just equal to 1. I think I'm about to teach you something new. That wasn't really the plan. So we get this, and now we can do, we're still going to do implicit differentiation. Am I going to do this now? I am going to do this now. So if I differentiate this here with respect to x, I have to do the chain rule. When I differentiate a natural log, I get 1 over the thing. So here I'm going to get 1 over y, and then I have to multiply by dy by dx. So I'm differentiating with respect to x on this side, and I'm differentiating with respect to x on this side. Over on this side, when I differentiate this with respect to x, it's really easy, it's just 1 over x. And then when I differentiate y with respect to x, I get dy by dx. So now we can collect up terms. And this is what I get. I get dy by dx times 1 over y minus 1 is equal to 1 over x. Now let's just go back up and have a look at what we're trying to get to. Well, I'm just going to write it out again. I want to get to this. So my goal is to get to dy by dx times 1 minus y is equal to e to the y. So I'm going to have to do a bit of work, but I know that y was equal to x e to the y. So I can keep going here. So that's where I'm trying to get to, but I haven't got there yet. I've got here dy by dx times 1 minus y over y is equal to 1 over x. That's just doing a common denominator. And then I get this, dy by dx times 1 minus y, I'm going to leave that like that, is equal to y times 1 over x. But y is equal to x e to the y over x, which equals e to the y. So we're done. So I quite like that method, even though I just thought of that while I was doing the video. Right, so as required. So let's go over that again. What did I do? Well, I started by looking at this thing here, and I just took logs of both sides. And I took the natural log, because that's very easy to differentiate, right? Because we know that the derivative of the natural log of x with respect to x is 1 over x. So by taking natural logs of both sides, it let me split the expression up, and I got something pretty easy. So that's what was nice about that step. This next step was using the idea of implicit differentiation. Okay, and the tricky bits in here are seeing that here I've got something y. So instead of just going dy by dx, I have to do implicit on this. I differentiate this with respect to y, and then I times through by dy by dx. This one was easy, and this one is also pretty easy. When I differentiate y with respect to x, I get dy by dx. The bit after that was just some algebra. So here I was collecting up terms I was getting all the terms with dy by dx in. And then I looked at where I needed to go, and I started to manipulate. So this step was getting a common denominator. And then I had 1i back up here, and I knew that I wanted to have a 1 minus y. So I multiplied everything through by this y. So this step was when I times through by y. And then I looked at my right-hand side, and I wanted to have e to the y. So I substituted in x times e to the y. And that was that way. But now I'm going to do it the way, if you don't take logs of both sides, how can you do it? Well, we've got y is equal to x e to the y. And remember, we're trying to show this, that 1 minus y times dy by dx is equal to e to the y. So differentiating both sides, I'm going to get this. Because the two sides are equal, their derivatives are going to be equal. I'm going to need to use the product rule and implicit on the right-hand side. On the left-hand side, though, it's pretty straightforward. I've got dy by dx. So now I'm going to have, remember, uv dash plus u dash v is how we differentiate when we've got a product. So here, I'm going to differentiate x with respect to x. And I'm going to multiply by the other function. And then I'm going to do it the other way around. So it's going to be plus d differentiate e to the y with respect to x times this one, which is x. So we, oops, sorry, don't know what happened there. We get dy by dx is equal to 1 times e to the y plus, now in here, I'm going to have the derivative of e to the y with respect to y. So it's e to the y times dy by dx times x. Now, I'm going to collect up terms that have got e to the dy by dx in them. So I get dy by dx into 1 minus e to the y x is equal to e to the y. But what do we know y is? Well, y is equal to x e to the y. So we're there. Right, we've got dy by dx times 1 minus y is equal to e to the y as required. Right, so as usual, there's more than one way to do that problem, and I think by slowly going through questions like this, you get quite a lot out of it. There's a lot of nice product rule and implicit in here, doing it the second way, and that's a really common pattern that you find with implicit differentiation problems. But if you do it the first way, you start to see the huge value in logs. So have a good look at this question. It's short and it seems easy. It's easy to get the answer, but it's got quite a lot of nice content. Thanks for watching. I'll do some more later on.